Okay, we're going to talk about something really important in calculus, and it's called the intermediate value theorem. Now, it's a really neat theorem. The technical jargon you can get lost in, but when you explain it conceptually, it makes so much sense. So we're going to take a look at a graph, and for the purposes of the example here, I'm going to give you some numbers. I know it says f of a and f of b, but let's pretend that this is 7 and this is 10. So these are y values, all right? So the concept here for intermediate value theorem is, let's say I plug in a number for x, a, and I get y equals 7. And let's say I plug in a number b, all right, and I get y equals 10 when I plug that in. My question to you, is there some number x, or in this case c, so is there a c, okay, where y equals 8? Well, because the function is continuous, the answer is yes. That there's no way that it goes from 7 to 10 without crossing, suppose this number, y equals 8. Okay? So that's the concept here for the intermediate value theorem. Okay, so if it hits a y equals 7 and it hits a y equals 10, and we know for sure, for a fact, that the function is continuous, then there is some point guaranteed where it has to have crossed y equals 8 at some value for x that we're going to call c. Okay, so that's the concept behind the intermediate value theorem. So let's take a look at an example. It says, use the intermediate value theorem to prove that 5x cubed minus 8x squared plus 4x minus 3 equals 0 has a solution between 1 and 2. So what we're going to do here is we're looking specifically at the interval from 1 to 2. Okay? What we're going to want to find first is f of 1 and f of 2. So I'm going to picture this graph, and I'm going to erase what I had here, okay, and I'm going to replace it with the numbers that I know. So let's suppose this is 1 and this is 2. All right, what we're going to first do is figure out, well, what's f of 1 and what's f of 2, because they say that it should equal 0 somewhere in between. So let's figure that out. Again, this graph is not really drawn to scale so much, or it doesn't actually match the problem, but we're using it for illustration purposes. So in order to figure that out, I've got to find f of 1 first, and then I've got to find f of 2. Well, that just means I just have to plug in. So let me go ahead and do that. All right, I'm going to go ahead and do that. And now I'm going to plug in 2. All right, I'll give you a chance here. You might want to pause your video to see if what these values are, maybe by hand or on your calculator. So go ahead and give it a quick pause if you'd like. Okay, now I plugged them in myself, and this works out to be -2, and this works out to be 13. So I'm going to replace that on my graph here with, suppose, a y equal -2 and a y equal positive 13. So the question is there some point where it crosses 0? Well, the function, it's a polynomial, right? And what do we know about polynomials? Polynomials are continuous. And here's the trick: everywhere. Polynomials are continuous everywhere. So the intermediate value theorem can apply, and we know that this is f of 1, all right, f of 1, and this is f of 2. So what do we know? We know that f of 1 is less than some f of c, which is less than f of 2. All right, so we know that for sure -2 and 13 have 0 somewhere in between. So let's suppose this is 0 at this point right here. So the answer, they're not asking us to find where it happens. They just want to know, can it happen? And the answer is, of course, yes, absolutely. So what we're going to do is we're going to write out our answer. And we could write this out in a sentence, okay? Because all it says is use the theorem to prove that there is a solution. Never does it say to find the solution, okay? So what we would do to find the solution is we'd solve it by setting it equal to 0. This one right here is a cubic. So there, it's probably a little more intense than we'd like, but that's okay. All right, we're not asked to find it here. So I'm going to write out f of 1 equals -2, and f of 2 equals 13, and f, not f of, just f, the function, it is continuous on 1 to 2. Why? Because it is a polynomial. Because it is a polynomial. Okay. And by the intermediate value theorem, and I'm going to abbreviate IVT, it's very common, there is a point where f of c equals 0. All right. And we continue with our inequality that I had already written, and we say because there is some f of c between f of 1 and f of 2. All right, there has to be some place f of c where it equals 0 because it crosses from -2 to 13, in other words. All right, so that's just a really nice little example on the intermediate value theorem, and the accompanying diagram here really helped us out. So I hope this video was helpful, and as always, if it was, like and subscribe.